Okay, so hi guys, here is the video for phase 3. So last video we did left-hand limits or limits from the left using an like we had the equation of the function or we had the algebraic version. We had the algebraic version of the function. And so we used our calculator in a table of values to find the limit as x approaches some number from the left. Now we're going to continue approaching some number from the left, but we're going to be using the graph of the function. Okay, so the directions given the following piecewise function use an arrow diagram to determine the left-hand limit, okay? And remember, the dictionary definition is this, the final, utmost, or furthest boundary, but we want to think of it as a number that we can always get closer to, but never pass. Okay. So we want the limit as x approaches 1 from the left of f of x, and f of x is this is the graph of f of x right here. Okay, so the arrow diagram, you kind of already saw them last time, but it goes like this. As x approaches, in this case, 1 from the left, that's what that little negative up top means, then y approaches what? And then it is this answer, whatever y is approaching as x approaches 1 from the left, whatever y approaches, that is the limit, okay? That is the number that as we approach 1 from the left, we can always get closer to but never pass. All right, so here's 1. All right, so my x values, I want to be approaching 1 from that left side. You don't have to draw that little arrow in. I just drew it in so you could see what I'm talking about. So on a graph, what you want to do is you want to take a sequence of points. You want to look at a sequence of points that are starting at inputs somewhere to the left of 1. Okay, like I could start here. I know when we were, like last time, we were starting at numbers super close to 1. But if this graph was blown up, I would, but the graph is not, or zoomed in. If this graph was like zoomed in close to 1, I could do that, but it's not. So I pick a point on the graph to the left of 1. Okay, with inputs to the left of 1. And then so the x value for this point is right there. Now I want my x values to be moving closer and closer to 1 from the left. So I gotta pick points on the graph with x values that are moving closer and closer to 1. So guys, you just kind of keep going. We got this sequence of points. All right. Now, there is a hole at 1. This open circle means that the function is not defined at 1. Okay, so for example, f at 1 is undefined. Okay, like f at 1, I'll say does not exist, I guess. So f at 1 does not exist, but that doesn't mean that the limit doesn't exist. So as my x values are approaching 1 from the left, guys, what are the y values getting closer to? What are the y values getting closer and closer to? And remember, there's microscopic points, leading all the way up to this open circle here. There's microscopic points leading all the way up to that open circle. So as we're approaching, so in this sequence of points, what is the y value that we are always getting closer to, but we're never passing it? What's the y value that we're always getting closer to, but we're never passing it? The answer is -1. You can just keep getting closer and closer. As we keep getting closer and closer to this open circle, we keep getting closer and closer to the y value of -1. So the answer is -1, that's the limit. Okay, now I'll go a little bit faster. So now we have the limit. Can I zoom in more? Oh yeah, that's probably better, huh? A little bit blurry. I'm getting a better camera. Okay, now the limit as x approaches 7 from the left. Okay, again, still from the left. So here is 7. Oh, I hate this camera. Video quality is awful. So we're approaching this x value is 7 from the left. So x is approaching 7 from the left. The question is, what is y approaching? So I'm approaching 7 from the left. So I'm approaching, like my x's are going that way. So just pick a point on the graph that has an x value that's to the left of 7, like there. And then as the x values move closer to 7 from the left, here's the points. There's the sequence of points. And then guys, so this line, it represents 7. So we actually, now we've got, we're getting really close. And it keeps going like this. Guys, this is an asymptote, all right? So these y values, there's not really a number that they're always getting closer to but never passing. These y values just keep, every consecutive one is just passing, is just passing all of these y values. So what's going to happen as we get closer and closer to 7, these y values are going down even more. And they're just going to keep going because this is an asymptote. So really the y values are approaching negative infinity. Negative infinity is not a number. Negative infinity just means that we are just continuing infinitely in that direction, in that negative direction. Oh, and by the way, infinity is kind of another way of does not exist. Really, the limit doesn't exist here because we would need, to have a limit, we would need a certain number that we were getting closer and closer to but never passing. So technically, like, the limit doesn't exist, but negative infinity is a more specific way of describing that limit. Okay, guys, now we're going to approach 5 from the left. So as x approaches 5 from the left, y is approaching what? All right, so I find 5. 5 is right here. I'm approaching 5 from the left. So I'll just pick points on the graph, to the left of 5. All right. And actually, like right up on the graph, so here's 5. I'll put like a little line there too, just so I can see like where, where the input of 5 is. So this sequence of points, I keep. So what are the y values as I get closer and closer to 5 as an x value? The corresponding y values are getting closer and closer to, they're getting closer and closer to 7. They're getting closer and closer to 7. But I want to make an observation here, guys. In this case, we've got f of 5 does equal 7. So here's a situation, just like when we were doing the interval thing, how sometimes like the end point, sometimes like the first number in the set was equal to the limit, but then other times the first number in the set didn't exist, but the limit did. This is a similar situation. This is what I was building up to. So in this case, the limit is 7 and the function value itself is 7. So that's going to happen sometimes. In this case, the limit was -1, but the function value itself didn't even exist. All right, so I just wanted to point that out because you're going to see both of those cases. Again, we've got -1 from the left. So x is approaching -1 from the left. Y is approaching. And so here's -1. And we want to be to the left of it and go we're going in this direction. So here is a case, again, where we have f of -1. It doesn't exist, or it's undefined, is another way of saying that. And, oh, actually, let me say it here too. So f of 7, actually, it does not exist. Okay. Does not exist. All right. So I'm getting closer and closer and closer to -1 from the left. And what are the y values getting closer and closer to? Well, guys, here's a case where we've got a constant function. This is a piecewise function. This part of it is constant. If you've got a constant function like this, it's not like we're getting closer and closer to a y value. We're like staying at the same y value, but it's the same idea. So these y values are staying at 1. So we say that the y's are approaching 1. I get it that they're staying there. It might sound different than approaching, but it's, that's how that is how it works. Okay, so the limit here is 1. Now, guys, when I was doing like these parts here, I'm trying to like illustrate to you that the limit as you approach a certain number is not, it sometimes is not equal to the function value. Like, for example, here the function value doesn't even exist, so the limit can't be equal to the function value. But sometimes, every once in a while, the limit, or actually often, the limit is going to be equal to the function value at the number we're approaching. And when that happens, it's a certain case that we're gonna be studying more in the future. Okay. Yeah, you don't have to do these like function value things. I was just doing that for teaching purposes. But there's that, guys. Let me know if you have any questions at all.